What keeps the moon in space? Have you ever looked up at the moon and wondered why it never falls to Earth? Every night, the moon appears in the sky, following the same familiar path. It has been orbiting our planet for billions of years, yet it never crashes into Earth or flies away into deep space. How is this possible? The answer lies in one of the most important forces in the universe: gravity. Gravity is the invisible force that pulls objects toward one another. Every object with mass has gravity, but the larger the object, the stronger its gravitational pull. Earth has a powerful gravitational force because it is a massive planet. This force keeps people, oceans, animals, buildings, and even the atmosphere from floating away into space. The moon also has gravity, but because it is much smaller than Earth, its gravitational pull is much weaker. The moon is Earth's only natural satellite. It orbits Earth at an average distance of about 384,400 kilometers. Although this seems incredibly far away, Earth's gravity is still strong enough to pull on the moon every second of every day. If gravity is pulling the moon toward Earth, then why doesn't it fall? To answer this question, imagine throwing a ball. If you throw it gently, it falls to the ground almost immediately. If you throw it harder, it travels farther before landing. Now imagine you could throw the ball so fast that while it is falling, the ground curves away beneath it because Earth is round. The ball would keep falling around Earth instead of hitting it. This is exactly what happens to the moon. The moon is always falling toward Earth because of gravity. At the same time, it is moving sideways at an incredible speed of about 3,680 kilometers per hour. Because of this forward motion, it continuously misses Earth. Instead of crashing into the planet, it follows a curved path called an orbit. An orbit is the path an object follows because gravity pulls it inward, while its forward motion carries it onward. This balance between gravity and motion keeps the moon safely circling Earth. You can imagine it like swinging a ball attached to a string. The string pulls the ball inward while the ball's motion keeps it moving in a circle. If the string broke, the ball would fly away. If the ball stopped moving, it would fall toward your hand. For the moon, gravity acts like the invisible string. The moon's forward motion keeps it from falling directly to Earth. Together, these two forces create a stable orbit. This same principle explains why planets orbit the sun. The sun's gravity pulls the planets inward, while each planet moves forward through space. Without this balance, our solar system would not exist as we know it. Gravity affects everything in the universe. It shapes galaxies. It forms stars. It holds planets together. It controls the motion of moons. Even light can be affected by extremely strong gravity near black holes. Scientists have studied gravity for hundreds of years. One of the most famous scientists was Sir Isaac Newton, who explained how gravity acts between objects. Later, Albert Einstein expanded our understanding by showing that gravity is related to the curvature of space and time. Today, scientists continue studying gravity because many mysteries still remain. The moon does much more than simply orbit Earth. Its gravity creates the ocean tides. It helps stabilize Earth's tilt, making our climate more stable over long periods. Without the moon, life on Earth might have developed very differently. The moon also changes the appearance of our night sky. Its phases, from new moon to full moon, occur because different portions of the moon are illuminated by the sun as it orbits Earth. For thousands of years, people used the moon to create calendars, predict seasons, and navigate across oceans. Even today, astronauts and scientists continue studying it. Future missions hope to establish permanent research stations on the moon and use it as a stepping stone for exploring Mars and beyond. The moon is not simply a bright object in the night sky. It is an important partner of Earth. Its orbit has remained remarkably stable for billions of years because gravity and motion are perfectly balanced. Every time you see the moon rising above the horizon, remember that it is traveling around Earth while both are also moving around the sun. The universe is constantly in motion, yet everything follows the beautiful laws of physics. The moon does not stay in the sky by magic. It stays there because gravity continuously pulls it inward, while its motion carries it forward. This perfect balance has kept our closest celestial neighbor safely orbiting Earth for billions of years. In the next part, we will explore this balance in greater detail and answer an even more fascinating question: what would happen if the moon suddenly stopped moving, or if Earth's gravity disappeared? Gravity versus motion, the perfect balance. In part 1, we learned that Earth's gravity constantly pulls the moon toward our planet. We also discovered that the moon is moving forward at an incredible speed, allowing it to stay in orbit instead of crashing into Earth. But how does this balance really work? Let's imagine a simple experiment. Suppose you are standing on top of a very high mountain with a powerful cannon. If you fire a cannonball slowly, it will travel a short distance before falling to the ground. Now imagine firing it faster. The cannonball will travel much farther before gravity pulls it down. If you could somehow fire the cannonball fast enough, something amazing would happen. As the cannonball falls, the Earth's surface curves away beneath it because our planet is round. Instead of hitting the ground, the cannonball would keep falling around the Earth forever. This idea was first explained by the famous scientist Sir Isaac Newton. Although it was only a thought experiment, it perfectly describes how satellites and the moon stay in orbit. The moon is always falling toward Earth. However, because it is also moving sideways at about 3,680 kilometers per hour, it keeps missing the Earth. Gravity continuously pulls it inward, while its forward motion keeps carrying it ahead. This creates a stable orbit. Think about swinging a ball attached to a string. The string constantly pulls the ball toward your hand. At the same time, the ball keeps moving forward. As long as both forces remain balanced, the ball continues moving in a circle. If the string suddenly broke, the ball would fly away in a straight line. The moon behaves in a similar way. Gravity acts like the invisible string. Its forward motion keeps it from falling directly toward Earth. This balance is not unique to the moon. Thousands of artificial satellites orbit Earth using exactly the same principle. Weather satellites help predict storms. Communication satellites allow television broadcasts and internet connections. GPS satellites help us navigate with our smartphones every day. None of these satellites stay in space because there is no gravity. In fact, gravity is very strong even hundreds of kilometers above Earth's surface. They remain in orbit because they are moving forward fast enough to keep missing the Earth. The same principle applies throughout the entire solar system. Earth orbits the Sun. Mars orbits the Sun. Jupiter orbits the Sun. Every planet follows a curved path because gravity pulls inward while motion carries it forward. Without gravity, the planets would fly away into deep space. Without forward motion, they would fall into the Sun. The universe depends on this delicate balance. What would happen if the moon suddenly stopped moving? If its forward speed instantly became zero? Earth's gravity would pull the moon directly toward our planet. Eventually, the moon would collide with Earth, causing a catastrophic event unlike anything in human history. Fortunately, this cannot happen naturally. The moon has enormous momentum, and there is no force capable of stopping it so suddenly. Now imagine the opposite situation. What if Earth's gravity suddenly disappeared? The moon would no longer be pulled toward Earth. Instead of traveling in a curved orbit, it would continue moving in a straight line through space because of inertia. This idea comes from Newton's first law of motion, which states that an object in motion continues moving in a straight line unless acted upon by a force. Gravity is the force that constantly changes the moon's direction, keeping it in orbit. Another fascinating fact is that the moon's orbit is not a perfect circle. It is actually slightly elliptical. This means the moon is sometimes a little closer to Earth and sometimes a little farther away. When the moon is closest to Earth, it is called perigee. When it is farthest away, it is called apogee. These changes in distance are small compared to the overall size of the orbit, but they can slightly affect the moon's appearance and the strength of ocean tides. Scientists have measured the moon's motion with incredible precision. Using mirrors left on the moon by Apollo astronauts, researchers bounce laser beams off the lunar surface. By measuring how long the light takes to return, they can calculate the moon's distance with amazing accuracy. These measurements reveal something surprising. The moon is slowly moving away from Earth at a rate of about 3.8 centimeters every year. This happens because of the interaction between Earth's tides and the moon's gravity. Although this movement is very slow, it shows that the Earth-Moon system continues to evolve over time. The moon has completed billions of orbits since it first formed more than 4.5 billion years ago. Throughout all that time, gravity and motion have worked together in perfect harmony. Without this balance, our familiar night sky would look completely different. Understanding the moon's orbit helps scientists explore much bigger questions about the universe. The same physical laws that keep the moon circling Earth also govern planets, stars, galaxies, and even spacecraft traveling to distant worlds. Every successful space mission depends on understanding gravity and orbital motion. The next time you look at the moon, remember that it is not standing still. It is racing through space while continuously falling toward Earth and yet never reaching it. This beautiful balance is one of the greatest demonstrations of the laws of physics. It reminds us that the universe is not random. It is governed by predictable rules that scientists continue to study and admire. The moon does not remain in the sky by chance. It stays there because gravity and motion work together in perfect balance, creating one of nature's most extraordinary partnerships. How the moon shapes Earth. Tides, eclipses, and the secret to our stable planet. The moon is much more than a beautiful object in the night sky. Although it appears quiet and distant, it has a powerful influence on our planet every single day. From controlling the ocean tides to helping stabilize Earth's climate, the moon plays a vital role in making Earth the world we know today. One of the moon's most noticeable effects is the ocean tides. Have you ever visited the beach and noticed that the water level changes throughout the day? Sometimes the sea reaches far up the shore. A few hours later, the water moves back toward the ocean. This natural rise and fall of sea level is called a tide, and the moon is the main reason it happens. The moon's gravity pulls on Earth all the time. Land is solid and does not move very much, but the oceans are made of water, which can flow more easily. The moon's gravity pulls the water on the side of Earth facing the moon, creating a high tide. At the same time, another high tide forms on the opposite side of Earth because of the way the Earth-Moon system moves together. Areas between these two bulges experience low tide. As Earth rotates, coastlines move through these high and low tide zones. That is why most coastal areas experience about 2 high tides and 2 low tides each day. Sun also affects the tides. Although the sun is much larger than the moon, it is much farther away. Because of this, the moon has a stronger effect on Earth's tides. When the sun, Earth, and moon line up during a new moon or a full moon, their gravitational forces work together. This creates especially high tides and especially low tides, known as spring tides. When the sun and moon are at right angles to each other, their gravitational pulls partly cancel out. This produces neap tides, which are smaller than normal. The moon also helps keep Earth stable. Our planet spins on an axis that is tilted about 23.5 degrees. This tilt is what gives us the seasons. Scientists believe the moon helps keep this tilt relatively stable. Without the moon, Earth's axis could wobble much more over millions of years. That could lead to dramatic climate changes, making the environment much less predictable for plants, animals, and humans. Many scientists think that the moon has played an important role in making Earth a suitable place for life. The moon also creates one of nature's most beautiful events, a lunar eclipse. A lunar eclipse happens when Earth moves directly between the sun and the moon. Earth blocks sunlight from reaching the moon, and the moon passes through Earth's shadow. Sometimes the moon turns a deep red color during a total lunar eclipse. This happens because Earth's atmosphere bends some sunlight around the planet. Most blue light is scattered away, while red light reaches the moon, giving it a reddish glow. This is why people often call it a blood moon. Another spectacular event is a solar eclipse. A solar eclipse occurs when the moon passes directly between the Earth and the sun. The moon blocks part or all of the sun's light, casting a shadow onto Earth. For a few minutes, daytime can become as dark as twilight. Solar eclipses are rare because the moon's orbit is slightly tilted compared to Earth's orbit around the sun. The moon is also responsible for the familiar phases of the moon. As it orbits Earth, we see different portions of its sunlit surface. This creates the cycle of the new moon, crescent moon, first quarter, gibbous moon, full moon, and back again. The complete cycle takes about 29.5 days. For thousands of years, people have used these lunar phases to create calendars, plan farming seasons, and celebrate cultural traditions. Another fascinating fact is that we always see nearly the same side of the moon. This is because the moon rotates on its axis at almost exactly the same rate that it orbits Earth. Scientists call this tidal locking. As a result, one side of the moon always faces Earth, while the far side remained unseen until spacecraft photographed it in the 20th century. The moon continues to influence scientific research today. Space agencies around the world are planning new missions to explore its surface. Scientists hope to build permanent research stations near the moon's south pole, where water ice has been discovered inside permanently shadowed craters. This ice could provide drinking water, oxygen, and even rocket fuel for future astronauts. A permanent moon base could become the starting point for future missions to Mars and beyond. The moon has quietly accompanied Earth for more than 4.5 billion years. Throughout that time, it has shaped our oceans, influenced our climate, guided explorers, inspired poets, and helped scientists unlock the secrets of the universe. Every time you see the moon rising above the horizon, remember that it is doing far more than lighting up the night sky. It is helping keep our planet stable, creating the tides, and reminding us that even distant objects can have a profound influence on life here on Earth. The moon is not just Earth's closest neighbor, it is one of the greatest reasons our planet has remained a stable home for life. What would happen if the moon suddenly disappeared? The moon has been Earth's constant companion for more than 4.5 billion years. It lights up our night sky, creates the ocean tides, and helps keep our planet stable. But have you ever wondered what would happen if the moon suddenly disappeared? Although this situation is extremely unlikely, exploring this question helps us understand just how important the moon really is. The first and most obvious change would be the night sky. Without the moon, nights would become much darker. During a full moon, its light is bright enough to illuminate landscapes, mountains, forests, and oceans. Many animals use moonlight to hunt, avoid predators, or find their way. Without it, nighttime would look completely different. The next major change would involve the ocean. Gravity continuously pulls on Earth's oceans, creating high and low tides. If the moon disappeared, the tides would not vanish completely because the sun also creates tides. However, they would become much weaker, only about 1/3 of their current strength. This would have serious consequences for marine ecosystems. In tides, many sea creatures depend on tidal changes for feeding, breeding, and survival. Animals such as crabs, shellfish, sea turtles, and countless coastal species have evolved around the rhythm of the tides. Weaker tides would affect beaches, estuaries, wetlands, and coastal habitats around the world. Ocean circulation could also change. Tides help mix ocean waters, distributing nutrients and oxygen throughout marine environments. Changes in this circulation could affect fish populations and entire food chains. The moon also plays a critical role in stabilizing Earth's rotation. Our planet spins on a tilted axis of about 23.5 degrees. The moon acts like a stabilizer, helping keep this tilt relatively constant over long periods. If the moon disappeared, Earth's axis could become much less stable. Over millions of years, the tilt might change dramatically. Some scientists suggest it could vary far more than it does today. Such changes would affect Earth's seasons. Some regions might experience much hotter summers and much colder winters. Climate patterns could become far less predictable. These long-term changes would challenge ecosystems and agriculture across the planet. Another important effect involves the length of a day. The moon's gravity gradually slows Earth's rotation through tidal friction. Billions of years ago, a day on Earth lasted only a few hours. Today, one day lasts about 24 hours. Without the moon, this slowing process would become much weaker. The change would not happen overnight, but over millions of years, Earth's rotation would evolve differently. The disappearance of the moon would also affect astronomy. Solar eclipses, one of nature's most spectacular events, would no longer occur. Solar eclipse happens only because the moon passes directly between Earth and the sun. Without the moon, this breathtaking phenomenon would disappear forever. Many cultural traditions would also change. Throughout history, people have used the moon to create calendars, celebrate festivals, guide farming seasons, and navigate during the night. Ancient civilizations carefully observed the moon's phases. Even today, many holidays around the world are based on the lunar calendar. Without the moon, human history might have developed very differently. The moon has also inspired countless works of art, music, literature, and mythology. Poets have written about it. Artists have painted it. Scientists have studied it. Astronauts have walked upon it. It has become one of humanity's greatest symbols of curiosity and exploration. Future space exploration would also change. Many space agencies hope to build permanent research stations on the moon. Scientists believe these lunar bases could become stepping stones for future missions to Mars and beyond. Without the moon, these ambitious plans would not exist. Fortunately, there is no reason to worry. The moon is not expected to suddenly disappear. It remains securely bound to Earth by gravity. In fact, scientists know that the moon is slowly moving away from Earth at a rate of about 3.8 centimeters per year. This movement is so small that it has no noticeable effect on our daily lives. The Earth-Moon system has remained stable for billions of years and is expected to continue for an extremely long time. The more scientists study the moon, the more they realize how deeply connected it is to life on Earth. What appears to be a quiet object in the night sky, actually one of the key reasons our planet has remained stable enough for life to flourish. Sometimes we appreciate something only after imagining life without it. The moon reminds us that even distant objects can have enormous influence on our world. Every night it silently circles Earth, shaping our oceans, stabilizing our planet, and inspiring generations of explorers to look beyond the horizon. Without the moon, Earth would still exist, but it would be a very different world. Our closest celestial neighbor has quietly protected and shaped our planet for billions of years. Amazing facts about the moon and the future of lunar exploration. For thousands of years, the moon has fascinated people all over the world. Ancient civilizations used it to measure time, sailors relied on it to navigate the oceans, and storytellers filled myths and legends with its mysterious glow. Today, scientists continue to study the moon because it still holds many secrets about the history of our planet and the solar system. One of the most surprising facts about the moon is that we always see nearly the same side of it. Many people believe the moon does not rotate, but that is not true. The moon actually rotates on its own axis. However, it takes almost exactly the same amount of time to rotate once as it takes to orbit Earth, about 27.3 days. Because these two motions are synchronized, the same side of the moon always faces Earth, scientists call this phenomenon tidal locking. For centuries, no human had ever seen the far side of the moon. It was not until 1959 that a spacecraft sent back the first images of the moon's far side, revealing a landscape very different from the side we see from Earth. Another amazing fact is that the moon has no atmosphere like Earth's. Without a thick atmosphere, there is no wind, no rain, and no weather to erode the surface. As a result, footprints left by Apollo astronauts are expected to remain there for millions of years unless disturbed by future missions or tiny meteorite impacts. The moon's surface, covered with dust and rocks created by billions of years of asteroid collisions. These impact craters tell the story of the early solar system and help scientists understand how planets formed. The moon also experiences moonquakes. Like earthquakes on Earth, moonquakes are small movements inside the moon. Some are caused by tidal forces from Earth's gravity, while others occur because the moon slowly cools and contracts. Although moonquakes are usually weaker than earthquakes, they provide valuable information about the moon's interior. Another interesting discovery is the presence of water ice. For many years, scientists believed the moon was completely dry. Today, spacecraft have confirmed that water ice exists inside permanently shadowed craters near the moon's north and south poles. Because sunlight never reaches these deep craters, temperatures remain extremely cold, allowing ice to survive for billions of years. This discovery is incredibly important. Water can provide drinking supplies for astronauts. It can also be separated into hydrogen and oxygen. Oxygen can support breathing, while hydrogen and oxygen together can be used as rocket fuel. This means future lunar bases may be able to produce some of their own resources instead of transporting everything from Earth. The moon is also helping scientists prepare for human missions to Mars. Because the moon is much closer than Mars, it provides an ideal place to test new technologies. Engineers can study how people live in low gravity, grow food, recycle water, and generate power using solar energy. The lessons learned on the moon will help make future deep space missions safer and more successful. Many countries are planning new lunar missions. Robotic landers continue exploring different regions of the moon. Scientists hope to collect new rock samples, study underground ice, and better understand the moon's geological history. In the coming years, astronauts are expected to return to the lunar surface for the first time since the Apollo era. Unlike the short visits of the past, these missions aim to create a long-term human presence. Future lunar bases may include living quarters, laboratories, communication systems, and scientific observatories. Some scientists even imagine building telescopes on the far side of the moon, where there is very little radio interference from Earth. Such observatories could help answer some of astronomy's greatest mysteries. Could humans one day live permanently on the moon? Perhaps. Although many challenges remain, including radiation, extreme temperatures, and limited resources, technology continues improving every year. Living on the moon would require advanced engineering, careful planning, and international cooperation. Another fascinating fact is that the moon is slowly moving away from Earth. Every year, it drifts about 3.8 centimeters farther from our planet. This movement is caused by tidal interactions between Earth and the moon. Although the change is extremely small, scientists can measure it using laser beams reflected from mirrors left on the moon by Apollo astronauts. The moon has also inspired countless scientific discoveries. By studying moon rocks, scientists learned that the moon likely formed after a giant collision between the young Earth and a Mars-sized object more than 4.5 billion years ago. This theory explains why Earth and the moon share many similar characteristics. Beyond science, the moon continues to inspire humanity. It appears in songs, paintings, poems, films, and stories from cultures around the world. For many people, looking at the moon creates a feeling of wonder and curiosity. It reminds us that even familiar objects in the sky still hold mysteries waiting to be explored. The moon is much more than Earth's natural satellite. It controls the tides, it helps stabilize Earth's rotation. It has guided explorers throughout history. It serves as a laboratory for future space missions. And it continues to inspire scientists to ask new questions about the universe. Every night, as the moon rises above the horizon, it reminds us that the universe is filled with extraordinary wonders. The same natural laws that keep the moon safely orbiting Earth also govern the movement of planets, stars, and galaxies across the cosmos. Understanding the moon helps us better understand our own planet and our place in the universe. The story of the moon is not finished. In the coming decades, new astronauts will walk across its surface. New discoveries will reshape our understanding of space. Perhaps one day, permanent human communities will live and work there. The moon has watched over Earth for billions of years. Now humanity is preparing to return the journey, exploring it not just as visitors, but as pioneers of a new era in space exploration. The moon is more than a light in the night sky. It is a bridge between Earth and the future, reminding us that curiosity, science, and exploration will always lead humanity toward new horizons. Thank you for joining this 5-part journey. Keep looking up, keep asking questions, and never stop exploring the universe.